for coming, and absolutely thank you Yelp for hosting us. Very, very nice facility here. So, first up, we're going to Brian from Yelp come and say a few words about this awesome company that we all use. Here you go.
Hey everyone, apparently I have 15 minutes to talk, but I was prepared for about 1 minute, so here we go. Welcome to Yelp, glad to have you all here. So today we've got two great speakers lined up for you. First we have Ivan, who is the security manager at Yelp, who's going to be talking about an open source forensics tool for OS X that we have, which is really great. I'm excited for you guys to all see that cool product that was developed here. A couple other notes that are not on this schedule here. We have a meetup again here on the 25th about ads. So if you're interested in that, you should check it out. Come find a Yelper and they can give you more information about that if you want. And of course, we're hiring. I hear you all are Mac users. You like Macs. We also use Macs, so it seems like a good fit. You should come work for us, something like that. Awesome. And yeah, so that's about my 1 minute now. So I'll go ahead and give it over to Ivan, who's going to talk about OS X Collector.
All right. This is just did it all here. Here. Come set it up. Yes. Oh. There you go. Show my slides. And some picture. There you go. Thanks.
Picture came in handy, huh?
Yeah.
It's almost happening.
Oh, you keep showing my slides. You're gonna win the magic sauce.
Go!
Hey everybody, we're good? Audio, video, you can hear me, you can see me. That's me. The dog is the dog I watch on The Office, but that's me, Ivan, and we're here to talk about OS X Collector. So OS X Collector is an automated forensic evidence collection and analysis toolkit for OS X that we built here at Yelp. So what are we doing here? Agenda for the talk. Who am I? So you can believe some of what I said. What problems are we trying to solve? Why do we go down a forensic collection route? Then more about forensic analysis. And then at the end, you'll all think, wow, that was wonderful. Let's clap for that guy. At least that's what I was hoping. So who am I? Yeah, I lead the engineering security team here at Yelp. So we work both in the application and product side, as well as our infrastructure and corporate side, doing product stuff and infrastructure stuff and incident response and detection and all sorts of good stuff on the security side. Pretty much if it says security, we'll end up putting our fingers into it. In the past, I managed our mobile team here at Yelp and our internationalization team, but you know, that was all in the past. So my real job is to protect this. So yes, it says careers and you should go to careers and apply, but the real thing that you should think about is like, okay, it's actually 31 locales that we operate in. It's like 73 million mobile users, thousands of employees, and thousands of employees is really what it comes down to. And that's what we're trying to protect with these tools. So lots and lots of countries, lots and lots of users, and lots of employees, all using Macs, all getting pwned sometimes. So let's talk about that a little bit. So what's our problem? My problem. So this is a sort of typical diagram of a corporate network as far as security guys look at it and see it. It's like, cool, that's what our network looks like? Yeah. Right? And then like if we add the security to it, it's like stuff's going on all the time. This was sort of our life, right? It's like, hey, suspicious callouts to network hosts and new admin accounts created and malware and unknown kernel extensions. And so sort of we have instrumentation on our endpoints. We run a variety of things, and they sort of tell us, hey, bad stuff is happening, or happened, or it's probably happening, or might be happening. And then we sort of just get this map, and it's like, on fire, the Death Star is on fire. I don't protect the Death Star, that was a bad analogy. But that's what we're up to. So we were sort of in this world, and it was like, wow, that's pretty scary as we instrumented our endpoints. So OS X, it has malware. And so OS X Collector, that's why we built it, because we found a lot of malware. InfoSec Taylor Swift and InfoSec Barbie, it's good stuff. Yeah, so people ask a lot, OS X malware, gee, I haven't heard of that. Isn't it just Windows malware? No, that's not the case. No, it's all over OS X. You should look around in your infrastructure, because it's there. Yeah, so we wanted to prevent malware at Yelp. We thought, hey, malware is bad, let's not do that. And so we needed a tool to help us with that. So you can't really prevent malware until you figure out where it came from. And like you can get a nice threat button map of where threats are coming, but none of this works. So like we just need to figure out where did malware come from. So we got a bunch of people together in the security team, and we built something. This is actually not us building it. This is a hackathon, but it's kind of, don't you wish you could build stuff like that? Just line everybody up and build stuff. Hey, we're done. Cool, guys. Didn't work that way. So in the talk, we'll give some free malware prevention tips. This is the first one, right? Enable click to play for Flash and Java. I think last month, all the browsers finally just did this by default. Maybe, maybe not. That's what he knows. I don't actually know anymore. But if you do that, lots of malware goes away. It's a good idea. So let's get down to the meat of it, forensics collection. So we have all these detectors on devices. They fire and they say like, hey, something bad happened, man. What are you gonna do about it? And we're like, we don't know. So we built this, an open source forensic evidence collection analysis toolkit. So here's the deal. I'm incredibly vain. Ivan is in fact an anagram of vain. If you like the talk, you should go and star our project on GitHub. If you don't like it, we gave you free beer and pizza. Your favorite. Star the project on GitHub. Like that's all I'm asking for. If you actually like it a lot, you could like go download it, use it. Just to show of hands, anybody who's actually used the project at this point? 10 people. I like this. Thank you to all of you. If you send me an email, tell me that it doesn't work or something, I'll still be delighted. It does work though, so don't worry about that. It's really easy to use even. So that was a big goal. Like you're going to do collection of data on an endpoint that has malware. So like user brings their laptop to the help desk and they go, yeah, I have malware, I have the Stuxnet virus, what do I do? And it's like, oh, that's too bad, we need to fix that. So we want to do something really easy to get all our forensics data off this machine. So OS X Collector is a single Python script. It has no dependencies that need to be installed. You just need to copy this one Python script. Maybe on a USB drive. Malware. Maybe from the network. Maybe the network will be affected. But however you figure out to get the thing on there, bootstrap problem, you just need to run it, and that's it, right? And then it collects a lot of lines of data. So everything it collects is data. This is the data collection phase. It's really easy. And everything it collects into JSON files. I actually think JSON is sort of like beautiful. If you're like JSON.org and there's like that visual BNF chart on the right-hand side, I've seen it. I think it's very nice. I think JSON's really nice. It's really easy to manipulate. And so this is like one line of output, right? So we saw like, hey, we wrote 35,000 lines of output. This would be an example of one line of output, sort of describing a single kernel extension or plist or something. Yeah, plist stuff about your eyesight camera. And there's lots of information about it. So we'll talk a bit about like what information do we want to know. So our goal is like get rid of malware. We're going to collect a bunch of information. Might seem like a lot of stretch, but this is going to solve our problems for us. So OS X stores lots of data in SQLite databases. You're probably all familiar with SQLite. You probably don't know. I didn't know until I made this. SQLite's motto is small, fast, reliable. Choose any three. Holy, yeah. No, that wouldn't have been what I made up for the motto. But I'm more ambivalent about SQLite. But Python loves it. This is real Python code, more or less stolen from OS X Collector, that actually dumps a SQLite table and dumps like all the data in the table as key value pairs. So it's like, you know, it's not that hard. Select everything from the thing, and then, you list the tables, select everything from each table, and dump everything into a dictionary. Yeah, cool. So it's pretty easy to deal with. And so OSX Collector, the code is very simple. If you find a bug, you can make an issue and say there's an issue on GitHub, or you can just fix it, because the code's easy. And then the other thing that OSX stores lots of data in isplists. So SQLite databases and plists are sort of like the registry for OSX, if you take a Windows analogy, right? You probably don't know this because this is like a Mac group. But the difference is they're scattered all over the entire hard drive. So OSX Collector tries to find them all. Plists are pretty similar, right? There's a bunch of different formats, JSON-like, Enterprise XML-y, whatever you want, but it's just data in files, and OSX Collector is really good at reading them, and that works great for us. So in building this, the goal was, hey, have something really simple, and we can just put it in a machine, any machine, it works right away, no big deal. And so it turns out that like it's really easy to deal with plists on OSX. So even in Python, there's this cool library, Foundation, that wraps Objective-C. So you can make system calls on OS X using Foundation. And if you look, if you're familiar with Objective-C, then you're familiar with having unusually and unnecessarily long function names. And Foundation is just exposing that to Python. And you see these unusually, unnecessarily long function names, but it's pretty easy to deal with. So once we figured this out, it was like, cool, game on. We'll definitely write this in Python because we write everything in Python and because it's easy to run. Then there's a couple of things, right, where you go, oh, Foundation doesn't expose it, but I really want to make this system call. I want to do something to the operating system. And so then it turns out if you want, you can like pretty much just write Objective-C in Python, which you don't want to do necessarily, but when you do, it's totally possible. So there's this Obj-C and C-type libraries in Python that let you do this. And so like this code here basically maps to this line of Objective-C over here. But that meant that we could basically do anything, which is what I said before and was lying. But now I'm saying now, and more or less telling the truth. So we're able to collect lots of data, kind of however we want, making system calls, parsing files, whatever we're going to do. So what do we collect? This is sort of a list of things that we collect, right? System info from the OS, info about kernel extensions, what have you downloaded, what applications are installed, what are the quarantines, startup items, browser info, email info, groups and accounts. It's a lot of stuff. Thousands of lines of stuff. I read this to you unnecessarily, you can read it yourself. But we'll talk about what they are, and then it'll be a little more interesting. So this is like a basic file. Like any regular file that we find, we'll start to collect this kind of info, right? So like downloads, kernel extensions, installed files, I don't know, launch daemons, whatever, we'll collect a bunch of information. So like, we want to kind of know what is this, it's a kernel extension, and you know, what are the file paths? Here's a file path, right? What are the hashes? What are the times? Who's it signed by? Whatever files we get, we're going to do the same kind of stuff to them. So like, times are really important. On OS X, there's probably about 9 ways to represent time in different SQLite databases, and the browser's represented, and the OS represents it like 7 different ways, because why the hell not? So OSX Collector normalizes date and time to very normalized stuff, which is very helpful. We'll see later. That is. Hashes are really important. So hashes for files, if 2 files have the same hash, they're probably the same file. That might be useful. If you found a bad file, you could go look for it across the rest of your machines with this hash. You know, people are really not into hashes anymore. They go like, oh, antivirus uses hashes and it's totally dead and it doesn't work. Hashes work, they're defense in depth. If you have a hash and it matches, you win. If you don't have a hash and it doesn't match, that's okay, we can keep going. So what other kinds of information are we collecting? Quarantines. Quarantines are cool. So you know when you download something and it's like, you downloaded a program off the internet. Is that okay with you? It's like, that's why I did it. But that information is actually saved in a plist. So every one of those that you've done before now is all in a plist. It's this plist. Preferences, com.apple.launchservices.quarantine events v2. And it basically just says this is all the junk that it uses to make these dialogues. So that's super useful, right? Like when a user downloads like freehockey.dmg and installs it, they probably download it and it creates a quarantine item. And if you were looking to see what has this user done lately, and they were like, they downloaded hockeysportsbet.dmg or something, you would see it here and you'd think, oh, I bet that's not good. Right, in this case, it's very benign. It's me downloading Alfred, which is like something nice. So let's talk about startup items. So there's a lot of ways to get stuff to run on boot in OS X. You probably know lots and lots of them. Launch daemons, startup daemons, all sorts of good stuff. So OS X Collector goes through all sorts of different things, I don't know, 10, 12 different ways that apps persist and launch at boot, and tries to enumerate what's installed on a machine. So when malware starts at boot, launches at boot, that's like game over, right? So generally when we see infections on machines, we will see that they've persisted in some way, so that on boot, before you even get a login screen, they go and hit the internet for updates or commands or control, right? That's really common, not just in like super advanced malware or Trojans, but nowadays even in adware and sort of more benign stuff. So it's like, oh, that's bad. So you really don't want startup items to be malware, which is kind of interesting. So here's a cool digression. Like you think, okay, hey, operating system, prevent malware from me. That'd be great. And there's this cool thing where on OS X, it has signature checking for malware, or sorry, for binaries. So if binaries are signed, then OS X will actually check the signature of those binaries against the rules encoded in the binary about how the signature should be checked. But if the binary is not signed, and if those rules don't match how the binary is signed, then it'll be like, oh, I'm not going to run you, you're obviously bad. But if binaries aren't signed, it turns out it just runs them, because whatever. So if you're making malware, what you do is you remove the signatures from things. It's interesting, we actually haven't seen any signature chain attacks, but I don't know, it'd be fun if we did one day. So another malware prevention technique, always use an ad blocker. Pretty much like, we put ad blockers in, and all this malware went away. It was really cool. What's my next slide? Oh, let's go back for a sec. Yeah, so what other stuff are we collecting? Kernel extensions, right? Kernel extensions are like your drivers in Windows. This is stuff that runs in privileged mode. All the downloads in your downloads folder, we want to know all of those. Turns out there's some really cool properties in the OS X file system. It actually tracks on downloads generally. It adds metadata to the file saying this file was downloaded from here. There's a tool called, I think, xadder or something on the command line. You can run it and it'll like list out for you like all the extended attributes of a file, including like where did it get downloaded from, which is usually pretty easy to figure out once you read it. All the applications that are installed, there's also an install list. So there's a plist, kind of like quarantines, that tracks everything you've ever installed. So install something, uninstall it, who cares? It's still there, right? All your browser history info, just everything about what went on in the browsers is sort of pull it all out. If you're using email clients, built-in email clients, we get all that information, and all the user groups and accounts, all that good stuff. So a bunch of data gets collected, right? And this is the collection phase. If you were doing this by hand, you'd be bored out of your mind. But the tool just sort of runs and does it for you in one command. It's easy. And then sort of the fun part, forensic analysis. Hi.
Hi, how long does it take to run?
It depends on how much data there is on your machine. If a machine is brand new or something, I think it takes maybe a minute or two. If a machine is several years old and no one's ever deleted the browser cache or history and stuff like that, it can take over an hour. So it really depends on how much data it's crunching through. The speed of the machine, because it's running on the host generally. You can actually image a drive and use a mounted image drive. It works great, but we don't generally do that. So it's really variable in time. Any more questions about forensic collection? Analysis is the cool part. Yeah, forensic analysis is the fun part. Like, collection is hard work and no one enjoys doing it, but once you have data collected, analysis is really fun. Like, if you said to me, hey, command line has this really rich syntax, you can do all sorts of cool stuff with it, like make typos, but anyway, it works really well. So if you just take the output of this, which is a big files JSON data, and sort of just grep through it and stuff, you find a lot. So it normalizes timestamps. So if you have some event, right? FireEye calls out at 11:35, or FireEye sees a call at 11:35 and says like, there was a call out on this machine at 11:35, something bad, right? Just grep from 11:32 to 11:38 and see what's in there. Like, maybe it'll be really obvious. Maybe they like install some malware, you see it all and all that stuff. Cool. It turns out like that works a lot of times. Sometimes you kind of want to get a little more specific, so you could grep for a time frame and then say like print out all the URLs that you've seen in that time frame. So this is like a little bit, fancy JQ stuff. It's not that fancy really. Or you could grep a single user, like, hey, sometimes you get an alert and it's like the admin user has malware. Like, oops, clearly that's us. But then we're like, okay, let's just see what's going on with the admin user, because that's fast and easy. So just manually grepping works really well. This got us from like, we can't solve it several days, to a couple of hours, generally. But after a while of doing this, we sort of said there's just a couple of techniques, dozens and dozens, but just a couple of them that we sort of use to analyze stuff. What if we just automate those? So it was like, if we analyze this, then stuff, and then profit, like we would just know. And so we actually have done that and built that. So this is, we have a grand analyze filter, though we have many filters that we'll talk about. And it just basically says like, hey, this is very readable output. Here's some stuff we don't recommend you do. And this is just a brief output. But we actually have an analyze filter that can look at this whole output of data and say, this is the bad stuff. And we'll talk about how that kind of works. So this is sort of a chain of filters that we've built. And so basically data goes into the first filter, and each filter sort of manipulates the data as it passes through until we get to the output. And you can run all these filters individually or chain them together yourself really easily on the command line, or run the fancy combined filters that we made. And it kind of helps us figure out what's going on. So let's talk about the fun part, the analysis. So the first filter that we do is a find domains filter. And so this filter is very simple. It has one job. It does one thing. It does it really well, it turns out. And that's great. And most of the filters operate that way. So we have some really abbreviated input data, right? We have a URL that goes in, and then from the output we see it augments the output data with the domains that it saw. This is like a very simple example, but it's pretty smart. It can find URLs that are in keys or values, or if there was like a query parameter here that was another URL, it'd find that. It's pretty smart. It does a good job of finding domains. It does a good job of normalizing them. And that's all it does. It's very simple. But now you have a better idea of what domains people have been visiting or interacting with. And then blacklists are really interesting. So obviously if you know something is bad, if you've seen it before, if you have a hash of some bad stuff from last week, you go look at it against the hashes that you found in here, that's good. Now you can know like, oh, the bad stuff from last week's here, we're done. So OSX collector is smart. It understands domains for blacklists and does some smart stuff with them. But you can use file hashes or parts of file names or really whatever you want, have it match. So kind of simple example, right? We have evo.com here. We've already run it through the domain filter, and we see that it found evo.com. And then we have a blacklist that we're comparing against that contains evo.com. And so then it says, oh look, I figured out that something on the domain blacklist is in this line. Simple, easy. If you saw that in the output, then you go like, oh look, that domain that we don't like, evo.com, there it is, but that's the problem. Hooray. So the blacklist filter does that. Yeah, major learning that I had in my life, domains that contain the words free or download or sports bet all serve malware. Downloads.cnet.com, we block this in our corporate network, you should too. It's all malware. So we do some other cool stuff. We go and talk to a bunch of networks, a bunch of services over the network that give us cyber threat intelligence. That's like a fancy buzzword, but I don't know, I can use it, I like fancy buzzwords. So we'll talk about the OpenDNS related domains filter. So we pay OpenDNS money to use their APIs and learn about domains from them. So this is sort of like, you can ask OpenDNS, hey, I got this one domain, do you know any other domains it might be related to? And OpenDNS is like, yeah, I actually do, which is pretty cool, and which is probably why we pay them, because not many people can answer that question. So basically, you can say, hey, I know about evil.com, what's it related to? And it can be like, oh, that's related to doubleevil.com and freelunch.com and torrentsandmalware.net, right? And that's cool. So the truth of the matter is, like, suspicious domains and IP addresses are often things that are related to them are suspicious. So what we do generally is we ask for what's related to any domain or IP that we're interested in, and then what's related to that. So we sort of get the second generation related stuff. And it's pretty impressive. So you can take, like, again, a good example is like a FireEye type callout where you have an IP address and it's like this machine hit this IP address. I don't know about you. I get these and I'm like, cool. Like, you have no idea what's going on. FireEye's not really helping you figure out the next step. It turns out that like the second generation related domains for an IP address are incredibly helpful. Like, you do this and you see downloads from those second generation related domains of apps or browser extensions or some other junk, and you figure out, like, oh, the dude Wayne here had downloaded this thing, and then a minute later it made a call out. So this really works. And the filter framework that we were talking about, it's smart. It has a base class that lets you call out to APIs, and it parallelizes them and runs them at thousands of calls per second and rate limits them and all this other stuff. So you basically just have to write a few lines of code that are like, here's the actual way to go get some data from the API. Here's a domain, you call this function, good, done. So we have a bunch of these, right? We look up at hashes and VirusTotal. If you're not familiar with VirusTotal, it's a service that's owned by Google nowadays. They basically just have hashes for files, and they know if they're bad or good. They run them against about 50 search engines, which is useful. Shadow Server is kind of the opposite. Shadow Server, they have a list of good hashes. So the hashes of stuff that came in the operating system to begin with. It's not always complete or whatever, but it's useful. If it's like, you know, the kernel driver that we all have in our operating system, then we don't really want to do a whole lot of work processing it, sending it to OpenDNS and all sorts of stuff. We can just ignore it. So Shadow Server helps us figure out stuff to ignore. VirusTotal has some domain reputation stuff. We have some algorithms and a filter to kind of do domain reputation stuff with VirusTotal, similar to domain reputation stuff with OpenDNS. We have other stuff that deals with IP addresses. It's kind of similar. But anyway, OpenDNS domain reputation. So this is a little different than related, right? Related is cool. It's like, what is related to this? Reputation is just like, here I have something. Can you tell me about it? So it's like, tell me about evil.com. And it's like, oh my gosh, they attack nuclear stuff. I don't know, right? That's a category. But it's like, you find out information like, hey, what is this? You know, if OpenDNS says like -1 status, it's bad, then you're like, oh, OpenDNS thinks this domain is pretty bad. That's not cool. Or maybe OpenDNS like gives you a bunch of numbers, and we come down and interpret these numbers and say like, oh, the prefix score, so the prefix of the IP address, the subnet effectively or whatever, is bad. So that's not good. So you can kind of figure out stuff. Is this does this domain name look algorithmically generated? So lots of malware generates domain names like on the fly using algorithms, and then it can change where it's talking. So it takes the time of day, and it sort of runs it through some algorithm, and it knows, given that it's today, at this time, I should go try to find some domains with these names and use them for command and control. So OpenDNS is useful here again to do that kind of stuff, right? And cyber threat intelligence is all over the news now. It's like the new APT term. You should just throw it in there liberally if you want to sound smart. Domain reputation, super useful. So yeah, we have this base class for APIs. It does all sorts of smart stuff. If you want to add your own, it's pretty easy. Malware prevention technique number 4, don't run Android. That's like more or less proven this week. Maybe I'm just editorializing. Maybe it's actually a good tip. I don't know yet. So let's talk a little bit about some other filters that don't have cool slides associated with them. So related to files filter. So a lot of times we get some information that we're starting on. Hey, we saw a call out on this machine, or OS query found something weird on this machine, a file we don't like. So as we run the whole thing, we can sort of tell it the name of the file that it found that we don't like. And what this filter will do is sort of look around through all of the data passed in and try to figure out, like, is something related to that? Do we see some web query that's related to this file name, right? Somebody downloading it, or downloading something that has a piece of the name in it or something, kind of does some smart breaking up of data or whatever, to try to figure out, like, what's going on here? Is this good? Is this bad? Whatever. And often you can find, like, given a file name of something that you think is bad, it'll just find the rest of the activity related to it, often, which is pretty cool, because then you get this little story. You're like, look, they downloaded something, they got something off a USB drive, they got an email, whatever, and you kind of figure it out. Browser history, super interesting. So this filter sort of takes all the data from the browser and spiffs it up really nice. So it'll make the browser history that comes out sorted in time and look more or less exactly like the output of like the history panel in your browser. It says it actually does cooler stuff than that. There's more information that doesn't get shown, like if you just look at Chrome history, for example. So it knows stuff like, was this, you know, a link that was followed through a chain of redirects, or did the user directly click on something to get here, or was this a hidden pop-up? Hint: hidden pop-ups are malware. So it knows a bunch of stuff, and that's really cool, and it can kind of help you out a lot. And then what we do is we have a filter that actually does all this kind of stuff in a big chain, and then recommends what you do next. So it says stuff like, yo, they downloaded this bad thing from over here, and they ran it, and they installed it, and it did this. And so you should block these hashes, and block these domains, and prevent this kind of malware from getting on your machines again, which was our goal originally, and it actually works. When we first started running this, before we started running this, we didn't really know what was going on, but it seemed like people were doing lots of bad stuff. As we started running this, we got some good ideas about what was going on. So sources of malware on OS X appear to be web downloads, or Flash or Java ads or whatever, infections that come off of USB sticks, or infections that come from email, whether it's webmail or whether it's in a mail app. Since we started doing all this a while ago, our infection rate from web downloads, which is what we can sort of control the best, is plummeted. We just don't get a lot of it. And mostly what we see is people plugging in USB sticks full of malware, kind of, you know, whatever, we can't really stop them from that. We're not going to turn off USB here in the corporation. Or people who open up spam. Usually when you dig into it, you can actually see them going to their spam folder and clicking on the spam. And that does infect you, it turns out, I learned. You might have done that already. I wrote all this just to figure it out. But so this actually works, and we actually greatly, greatly reduced the number of infections due to web. Hey.
Hey again. OS X collector produces this JSON input. Do you include this analysis chain in the open source?
Yeah. All of this is open sourced.
Sweet.
You could start it from 2 accounts if you want to. I'd be fine with that. So that's kind of some more of the filters. So this is the part of the talk where you're like, wow, this was wonderful. I'm going to go back to my corporation and run this and actually clean up my malware problems and contribute back to the source code and send out in love letters. All sorts of stuff like that. Yeah, I would love to know if you use it. Send us pull requests if you have stuff to fix. Open issues if you have stuff to fix but you don't want to fix it. Somebody will probably fix it. If you're interested in stuff like this, right, 2 good hashtags for Twitter. These are actually like, you know, DFIR, digital forensics and incident response, and Mac forensics. Those are the ones to look at, right? Lots of really good stuff. There's a lady, Sarah Edwards. She has some really, really awesome forensic stuff on her website. If you go to the README on the GitHub page, there's links at the bottom, point you at Sarah Edwards' presentations. How things basically work is Sarah figures everything out, and then I read her presentations and code it up. So that works, it's cool, she's friendly. So there's lots of really smart people who know lots of really great stuff. These hashtags will find you some cool stuff. If you have questions, happy to talk. Love to hear more. You can follow me on Twitter. Like I say, I'm vain, so I appreciate it.
You mentioned the OpenDNS part is premium. Is there any other parts of that analysis that cost?
So of the stuff that we run OpenDNS premium stuff, right? Costs money. Tell them that I sent you there. Tell them that I promised you you'd get a really cheap price. Maybe a lot. Cisco bought them. I'm sure their prices are super cheap now. Just guessing. VirusTotal, we have a VT Intelligence subscription. If you don't subscribe to VirusTotal and pay them some extortionate price, they will let you make 4 requests per minute, and it will work. It's just real slow. If you pay them some amount of money, you can make some amount more requests per minute, and it may be fine for you 4 requests per minute. And if you mess with the code a little bit and tune things, you could make less calls to VirusTotal if it's taking too long. Those are the only premium things I think right now that we've integrated. It's really easy to sort of integrate your own. I only know of 1 or 2 companies who've actually went and bought OpenDNS and bought VirusTotal like we have as a result. I know a bunch of companies who are using it. reasonably successfully without it, so I don't think you need to go pay for these things. I do actually think it works better than not doing that, but you can get away without paying for it.
What events trigger a OSX collection? Like, do they go, like someone goes to a bad URL, you're like, oh shit, a bot just runs and grabs all the information from the computer and spits out?
Not that cool, but it is pretty cool.
Like someone has some malware on the computer and you collect it.
Yeah, so it's a little more manual. So Brian, that long-haired guy who introduced us for 1 minute, right? He wrote this really cool tool. So all of our endpoint collection stuff, whether it's OS query, whether it's Sophos, whether it's our network detection stuff, whatever it is, whether it's info from OpenDNS or DNS logs, whatever it is, it all aggregates into Elasticsearch for us. Then we use this other cool open source tool that we open source, ElastAlert, to sort of dig through all that data and figure out, like, when do we think stuff is bad? And Brian wrote a bunch of cool code that sort of looks at all those alerts, decides if we think those alerts are bad. If we think those alerts are bad, it goes and grabs more information about what happened, grabs more information about whose machine is this and what office do they work in, and then it like sends mail to the user and it's like, sorry, you're owned. And then it like sends mail to help desk and it's like, sorry, go collect the machine. And then it like opens a ticket in Jira so that whoever's going to do analysis in the end and actually figure out what went wrong has the information. I'd love to go further than that. I'd love to like use Fabric or something like that, SSH to the box, run this, grab all the data, upload it to S3, kick off automation to go analyze it. We haven't done that yet. It's not as big a deal for us anymore because as we block stuff on the edge, the incidents go way down. What's interesting is that the stuff we get now is usually more interesting than it ever was because we're sort of seeing it and finding it. But some amount of automation, but it gets pretty manual. Some people in this room often go out and grab those things and take them back to our IT help desk where they figure out what's going on and start running OSX collector manually.
Got a question from the stream. Wanted to know why you went this route instead of leveraging Audit D.
Why did we go this route instead of leveraging Audit D? I think Audit D is a different solution entirely. Audit D is a real-time stream of activity, and you can kind of see in real time, okay, what's going on machines. It's way noisier to get all the information that we're looking for. And Audit D doesn't really see all the information that we're looking for. Audit D sees something entirely different. I really like Audit D. We're using OS query on our corporate infrastructure today. I think our next step, if we want more information than what OS query can give us, or what the kernel extension version of OS query, which is coming out soon, can give us, would be Audit D. But I think actually by the time we're ready to roll it out, which is like in a month or two, OS query will kind of replace the functionality that Audit D does. I think Audit D is cool. Like sometimes I have a bunch of root Q&A at the end of this, like why didn't you X? I think there's a lot of really good ways to extend this, or a lot of other really good sources of data. Audit D is cool.
Sweet.
Have you considered becoming your own reputation database where experts can review things and then put reviews up and then other people can vote on that? And can you be the Yelp of this, of malware? And people can report that malware and be a database unto itself. You have this information now.
No, I mean VirusTotal is that place. VirusTotal is the Yelp of malware. I never thought of it like that. If they advertised that way, I bet our marketing team would call them quick. But they are the, like VirusTotal is the Yelp of malware, and it's free, right, to just look up stuff. So you should go there.
You send queries out, you don't maintain a local cache of these responses?
We maintain local information for all analysis that we do, but we're not VirusTotal, and we're not rebuilding VirusTotal.
Hard work in building filters that have been the results of this whole process. Share that.
We share all this code, but we just rely on VirusTotal to have the data. So one thing about threat intelligence is it's constantly changing, right? So you can think about like, I told you like downloads.cnet.com, don't go there, it's bad. I mean, odds are like either no one will go to cnet.com anymore because it's so bad, or they'll fix it and then it'll get better again, and then my advice will be bad. So any cyber threat intelligence, whether it's what is malware or what domains are related to what domains or whatever, that stuff needs to be super fresh and it expires really quickly. And so we're not in the business of being a catalog or a repository. We'd rather use somebody else's. I don't think like if you want to do it, I've heard of people doing it. It takes a lot of work. If that's what you want to invest in, you could do it. You could be really successful. For us, we thought, no, you know what? we could pay VirusTotal some amount of money, and they would do it for us, much cheaper than we would do it ourselves.
So I may have misunderstood when you said it, but you were suggesting that we use ad blockers?
Yeah.
Do you actually install it on your fleet of Macs?
We install ad blockers on every machine. We whitelist Yelp, which is what I recommend
I was just
you
gonna
do.
say.
Yeah, no, you should whitelist Yelp.
Ad-supported webpage.
You should whitelist Yelp, and then you should install an ad blocker to block the rest of the stuff. That's what I do. And we do that on all our machines.
That totally works.
No, it absolutely works. I recommend it. And the ads on Yelp, we already announced. They're like first-party ads nowadays. I don't even think AdBlocker blocks them anymore. So I don't even know if we need this anymore to block to whitelist ourselves. We don't serve bad ads. Facebook ads are very targeted, and that's great. I bought shoes off of it. Wow, it's turned quick. What else could I answer for you? Hi.
Can you think of other uses for this code?
Can I think of other uses for this code? We have taken bits of this code, especially these filters, and pulled them out into all sorts of other alerting infrastructure that we have. So if you get an alert from something, right, and you're like, hey, something happened, and it's related to a domain, then like, why not get some domain information? Or if something happened and you have some whitelist or some blacklist to think about it, that's cool. So like, when we get information from OS Query, and OS Query says somebody installed a new kernel extension, we say, oh, do we know about that? Whitelist, blacklist, cool. Don't know about that. Oh, VirusTotal, what do you know? Shadow server, what do you know? And we do that, and then we handle those alerts in those kinds of ways. And if it knows enough, we can just be like, cool, we're done. It's cool, it's benign, it's horrible, what do we do? Like, we can know. So we take a lot of this code and kind of pull it out into other little pieces and parts. It's kind of a foundation for thinking about how would you analyze data. There's lots of other stuff you could do, but yeah, we use this stuff for other stuff. Stuff for stuff. Hey.
You mentioned you're already using OS Query. Why did you write your own code to access parts of the system that OS Query can already access?
Why didn't we just use OS Query? We wrote this before OS Query was publicly around. We started using OS Query before it was publicly around, but we wrote this even before that. Could OS Query do all this stuff? Potentially, yes. There are not tables that do all this kind of stuff, and it doesn't do any analysis like this. But for the collection side, could you replace it with OS Query? Yeah, sure. You can make it happen. If you do, that'd be cool. I'd use it. Other questions? Cool, thank you. That's me. If you have more questions, if you like this so much you want to work on it your whole life, whatever.
All right, that was awesome. Thank you. So we're gonna have Jason up next. Let's get the display swap back over, right? We need to go to the crystal. Back to Keynote. Oh,
I gotta use both of them. I forgot.
Hey folks, this may not actually go 30 minutes because I saw lots of faces actually at the Mac Admins Conference. However, we'll make fun with it. So we're actually going to talk about the PSU Mac Admins Conference. I'm going to do a quick little wrap up for you guys so you guys can kind of know what happened at the conference, maybe why you should attend, why I went to the conference. Just let everybody know who I am. Yeah, I'm Batman. I'm a huge Big Bang Theory like enthusiast. I love to have all 7 seasons on Blu-ray. The 8th is already pre-ordered, by the way. Actually, no. I'm a father, as everybody probably saw my newborn, or he's graduated to infant status according to my wife. My 9-year-old, love playing video games, of course, Big Bang Theory. I'm a Macbrained board member. I'm a Mac admin over at Lawrence Berkeley National Lab. And some people know me as Token, kind of. Yeah, but really, some people do. All right, so let's talk about, I got the head checks. You got to get it in there. So let's talk about the 2015 Mac Admins Conference at Penn State. So let's give a little bit of overview, kind of who went. So over 600 Mac admins went, actually. There was a ton of great content and information. There was actually over 59 sessions packed into 3 days. So I don't know how many other conferences you guys go to or that you attend where there could be maybe 4 in a day, or there may only be 8 in a day. There's over 59 packed at this conference in the 4 days. In the first day, there was actually workshops. But you guys, I'd say go, because it's a great place to get knowledge and talk to just great people, great individuals. So, day one. Day one, there were workshops, and they were all day workshops. Now, these were very long workshops. I thought that maybe they were going to go, say, 4 hours and 4 hours, but you got 8 hours on this particular topic. So you were able to go in depth on all the materials that are, say, on the screen, and say get any question answered that you need to get answered. The All Things Security workshop I heard was pretty neat. They actually were able to make fake fingerprints and get past the sensor on the iPhone 5S, actually, so that was pretty awesome. Tom Bridge and Chris, I think it's Day's talk, or I'm not sure how to say it, the fundamentals of Wi-Fi talk, I heard that was actually mind-blowingly good. Lots of great reviews. Now, if you were more the advanced users, the intro, Johan's talk for the introductions to Cocoa development and the reverse engineering on OSX, that actually was a great, great talk. Kind of wish I would have went to that one. However, for my organizational needs, I needed to actually go to the packaging workshop with Greg Daigle. Sam actually filled in. However, Nick was there in spirit. And if Sam is here, which I did believe I did see him, he is a fantastic, fantastic fan of Composer. He's probably the most expert person in this room on using Composer. So if you need help, talk to Sam. And then, of course, there was an Apple workshop presented by an Apple rep. Take it that what you will. So, for me, I actually went to the packaging workshop. They gave you a bunch of great applications to look at packaging. So, suspicious package and pacifist. So thanks, Nick and Greg. They actually went over GUI packaging. So if you are not, say, a command line buff and you're not a fan of the terminal, even though I kind of find that hard to believe, say, with this particular crowd. But if you're not, you could still use pure GUI apps to make all of your new packages that you're going to deploy to everyone. If you're not a GUI fan, you can always use command line tools. And you can actually examine the apps, build the apps, and kind of just play around with them as much as you kind of need to. And also inside the workshop, we actually built, I believe it was Google Chrome, a Firefox, and I can't remember the last app, but we built quite a few applications, and they definitely answered any questions of either why you should use a certain tool, why you should not use a certain tool, but it was a lot of great fun. So, tools for a conference. Every conference has, when you go to a conference, it's always, do I bring my laptop, do I bring an iPad, do I just bring a notebook, paper, pen? Kind of what do you need to be prepared for this conference to make sure you get the most out of it, say for your organization, for yourself, whatever you want to use. I actually hung out with Wes quite a bit. So he had some great tools. Dodge had some great tools for me. So one of them that we definitely use, Pickles. It's actually a bar down in right near Penn State. So it's a great place. For those who have been to the conference as well, they have a bar called Legends downstairs. A lot of great conversations. I actually talked with Rich Troughton quite a bit down there regarding some Python and some other things. So great talk. And lots of Yeeling beer. Lots of cases of that go around. You gotta have lots of great conversations. So those are probably the tools that you need for the numbers. Those are just a place where you have some good times. The tools actually in this conference that I found very interesting and unique that I haven't seen at conferences that I've been to before. People actually decided to try to crowdsource information and just share knowledge in real time. So we were actually able to take, if you say, oh, sorry, no, seriously, yeah. We're actually able to take tools like Slack and put, say, a Google Doc inside of Slack, which then everyone then would hop into, even if you weren't in that talk, and start taking notes simultaneously all at the same time, and you had notes in real time. And then at the end of that, say, talk or during the end of the conversation, somebody decided to put all of those notes inside of a Google Sheet, which is made publicly available for everybody to review any notes or anything, slides or videos about any sessions. And some information was still shared over IRC for those people who still use IRC, which of course it is still used heavily. So these are actually the tools that you actually needed for this conference. If you went to any one of these tools, you would have been at every single talk while being in one talk at the same time. So it was very interesting. This is the first time I've seen it because I've been to quite a few, they did it well. And not that the conference did it well, but the individuals who attended the conference did it very well. So these are 4 tools I would suggest everyone from now on moving forward. If you go to a conference, use these 4 because you could really help out an individual, say, who can't attend the conference. So let's kind of get into the meat and the potatoes. Of course, there's 59 sessions. I'm not going to review all 59 sessions. It's not going to happen. If you wanted to see all 59 sessions, they have the notes, the Google Doc, and the website and YouTube to review all 59 sessions. But I'm going to kind of go over the sessions that after talking with individuals who went to the conference, these are the sessions that they talked about, say, the most for each particular category. So on day 2 of the conference, there was actually a great talk, Entering the Awesome World of S&MP. It's dangerous to go alone, take this. That was actually a really fantastic talk. Tom Bridge gave I think it was an hour-long talk about tools that you can use, whether they're Wi-Fi, documentation, wow. I can't even remember the list. That's how long his list actually was of tools to actually use. That some are free, some are not free, some were quite expensive, $400 or $500 or whatever it was, but he said that it would actually really, really help you. The office talk was jam-packed. I actually had to walk out. Ben tried to save me a seat, and I mean Ben Gross, I see you over there. He tried to save me a seat, however, I was very, very slow, so I actually had to miss that talk. Rich Troughton gave another great talk on documentation. If you really want to take a vacation, I suggest you learn how to write stuff down. Point blank, period. You want to go on vacation, write it down. And write it down where somebody actually can understand it, not where only you can understand it. One of the big things is if you are using Casper and you want to have a monkey-like experience as far as automating your installs and downloading your software, if you're not using Auto Packager or Auto Package and or Auto Packager as well with the JSS importer, something is wrong. And a lot of people were not. However, after that talk, they were enlightened by that. There was a great talk on something called Chef. The Facebook guys tend to like that a little bit, just a little bit. And the talk to 12,000 Max and beyond, or I think it's 16,000 Max now they have and beyond. 17. So 17 now. See, look at that. Real-time updates.
It's 18 now.
18? There it is. 18. People really love that talk. They didn't realize what Chef actually, what it could do for them, what it could do for their infrastructure, how they actually would implement it. So just to have Mike get on stage and kind of let people know about that, it was a great tool and a great resource, and he actually ended up having a conversation later on that night with someone in a bar who has, say, I think they had 10,000 Max or something like that, and what they could do to try to help themselves kind of get over that hump. So that was a great talk. Docker. People who don't know about Docker. If you don't know about Docker, read. Do something. Talk to Nick. Nick did a great talk on Docker. The free your NetBoot server with the BSDPY by Pepin was a great talk. People loved it. It was really fantastic. So Google had a great talk there. Ed Marzak, he helps run MacTech LA, the conference down there that runs every November. Great talk for them. Check it out. It's still on YouTube. For the advanced folks, if you like working with system frameworks in Python and Objective-C, one of ours did that, James. He's not here today. He did that talk, great workshop. It was really, really fantastic. And the Let's Make Some Plugin Decisions, that was a great talk. It actually started some interesting conversations on IRC about whether or not you should really be doing that, but you can go back to the log and kind of check that out. So, takeaways. People are falling in love with Docker. If you're using Casper, you should be doing that. Talk to Dodge about going to the supermarket with Chef. Google has stuff besides Google.com. And if you need a cool list of tools, kind of check out Tom Bridge. His list is pretty gnarly. Day 3. That's a lot like for day, and think, on the previous slide when I did day 2, that was only what, it was three, I think nine talks I actually posted. There were significantly more talks than that on that day. Those are kind of the ones that I just fell in love with. So with some of the Disney guys, they do Python talks usually every year at some of their conferences, Greg Nagel, and I'm blanking on the other, and Matt Schinniger. He did an awesome talk on 12 Unix commands everyone should know. At this conference, there was definitely a range of, beginner, advanced, intermediate, super advanced. Probably should not be at this conference because they're so advanced. But the 12 Unix commands everyone should know, that was a nice little refresher. So if you haven't used the terminal in a while, and I'm going to say a while, like a long time, this is a great course to kind of get your bearings. You suck at email. So I definitely wanted to attend that talk. I kind of suck at email somewhat, but I do respond to all my emails, so I guess I win in that category. This was a packed talk. It was standing room only, and pretty much if you didn't get in, you were stuck at the door, and everyone who came out said, you just missed a great one. And so I was one of those guys, so they told me, you just missed a great one. But I'm going to go back and kind of watch that one on YouTube. Deploy Studio, everyone knows what Deploy Studio is. If you do not watch talk, it'll take you from, you'll get some nice skills, nice assets from that. Like the Yelp talk where they were talking about OS Query, Mike Arpia and the guys over at Facebook, once again, another great tool they released. Everyone fell in love with that tool. They said that they're going to try to go home and implement that as soon as they possibly can. So if you have not really taken a good look at it, I suggest you do. It probably could help your infrastructure. Using auto package for Windows software was probably my most mind-blowing talk that I went to. Only because you would think, it's only Mac and you're going at a Mac conference, why are you having a Windows talk? I don't know, does everyone have a 100% Mac environment and not a single Windows machine that they're servicing? How many people have it? 2. 3, yeah, right, you have them, yeah.
I don't have to.
You don't have to. Yeah, you don't have to, but you don't count because your corporation has it. So we have 2.5 people. We'll give you guys that. 2.5 people don't have some type of Windows or don't have Windows in their environment at all. If you can automate your Windows patches and installs, why wouldn't you? If you do it on your Mac side, why wouldn't you do it on the other side of the house? So that was a great talk to just take a look at, see how it all goes. They are actually using it with using it to help them with their Big Fix instance that they currently have. So if you have Big Fix, definitely talk to them. The guy who was halfway responsible is sitting in the crowd, James Stewart. So if you definitely want to talk to him about using that, definitely do it. He's over at the team at UC Berkeley now, so check it out. Of course, we all love, test. We never just roll something into production and just say, hey, it's ready to go, right? Right. So, virtualize your stuff, test whatever you can test. Great talk. It was actually split between Rich Troughton and, is it Joseph? I can't say his last name, but because I'm going to butcher it, so sorry, Joe, if you're on the feed. But he did a great talk, and he actually blew up Rich Troughton's face to the size of like this screen, and said, if you're attending my talk, go attend this guy's talk because he does testing and virtualization better than I do it. It was pretty hilarious. He built his own tool, vFuse, which is actually on GitHub to actually test with VMware. There's actually those who know Nagios. There was a great talk on Nagios. And probably the talk of the day, at least I thought the talk of the day that I attended, was the open and or free source, closed source cage deathmatch. with Ben Toms and Alistair Banks. Quite hilarious. Watch it on YouTube. That'll probably be, you'll get your money's worth out of that one. So, takeaways. OS Query. People were amazed. They want to use the tool. Soft skills are some of the best skills. If you don't have soft skills, you need to get them. This is Joe. Automated VMs with VQs and rich time. It's probably a good idea. And then last but not least, Alistair Banks, Ben Toms, open source and software shout out. And I think Alistair definitely won that battle. So that was kind of the takeaways from day 3. Finally, day 4, the finale. This was actually the lighter, of course, of all the days since everyone's going home and the conference ends at noon. So these are kind of definitely more of the beginner and intermediate courses where, get for system admins, DNS inside and out. They actually had the shop on Python or something on Python, another Docker talk. I actually went to the Git for sysadmins. Half of that is I went to half of the DNS inside and out. 2 great talks, kind of split. I wanted to see what they were both about, see if there was anything I can learn that I did not know previously. So that's why I snuck out of the DNS one and went to the Git one. But I still had some great company. I actually sat next to Elliot back there for much of it, so it was a good time. And then for the intermediate ones, I went to the sysadmin guides to Python. I've heard some people say that Python is only good for web development. So that was definitely an interesting conversation I had with that. So I definitely want to point towards that conversation, and of course, Docker. So takeaways: if you're not using GitHub to either contribute and/or just use the software, period, I suggest you do it. And if you're not doing some form of source control, version control of any of your code or anything like that, do it, because it will save your bacon. So, kind of final thoughts. I attended the conference because I heard just great things about it. Last year I skipped out on it, and I went to DEF CON instead of going to this, because it's DEF CON. Who doesn't want to go to Vegas, right? But I thought that this would be a great step or a great advancement for my career. I got to talk to a lot of amazing people who were eminently more smart than I am, and they could just provide the right amount of just kind of insight and just advice, or even I can pull up my laptop in the middle of a bar and say, hey, let's talk about this problem, and then we can code out the solution literally right then and there. So that was just a great tool, a great resource. I've actually met a lot of great people from there who I now still talk to now. James Stewart is one of them, Gregory Cash. I've met a lot of great people from that conference who I now will move forward with in my career. But if I need some help, I need some type of advice, it'll be a great kind of tool or great asset to actually use. So it's a great conference to go to. I suggest if there's one conference you want to go to that's kind of Mac related besides the one that's in Sweden, this will definitely be one of the ones to go for. Sweden, because it's out of the country, right? Who could go wrong with that? So, the save the date's already up. If you can go, book your hotel now. Book your hotel, get your flights, do whatever you got to do. Talk to your manager, start lining up your emails, whatever you can, but go. 27th to the 30th next year, right before the holiday, so it's good timing too. I suggest you guys go. I want to give you guys a list of resources. So there's actually the site, there's the conference resources. They've actually started already posting the videos on YouTube. Of course, our site is one of them. I actually made a short link for the notes. So the notes, if you want to actually look at all the notes that everyone took about the conference, they're there. Of course, IRC and Slack. And I actually did a personal post about this on my site that you can actually check out. So that's kind of all it is. Talk to you guys later.
All right. So we're going to have Dana up, and she's going to talk about some really exciting stuff we have going on in the next few months.
Cool. So, little special announcement. I hope it's a surprise. but I'm gonna have you guys guess. What did we do last year that we haven't done this year yet? Any guesses?
Free beer. Oh, wait.
Such a lively crowd.
You guys are really good.
Contest. T-shirts.
Hack the Mac!
Come on, guys.
Hack the Mac!
Give blood.
So this year, we're continuing our second annual Hack the Mac. We're actually super excited about it. And here to present the theme, I actually thought that we should bring on Mike Dodge.
Hey guys, how's it going? You guys ready for this? Did you like last year? Woo woo. Yeah. All right. Okay. So yeah. So this time around, we want you guys to create a application or utility that solves a common problem, same as last time, but this time it's going to be based on UIs, and a web app is going to be one of the things that you could potentially do. Like a good example of Monkey Report, or there's plenty of others. And potentially a native app, like the winners from last year, which was Auto Packager, or some of the other entries that were in here from last year as well, like Mac Health or IT Health, yeah, which was really cool because it's gamifying stuff, but yeah. And then, or like other projects that are already out there that weren't a part of the hackathon, like Cocoa Dialogue and many others. There's a bunch of them. Cool, so the two categories, like we just said, were user-facing and admin-facing in web and native. User-facing, like Managed Software Center or Monkey, and admin-facing, like Margarita by Jesse, and Managed Software Center or Monkey by Greg Nagel. And cool, so here's some of the rules and breakdowns. So it must have a GUI. It must provide value and be generic enough that anyone can use it. Must be clear and well documented. That's where I'm out. Must be available on GitHub. Must be available to present in November, and must be limited to at least 3 contributors. So yeah, we'll talk about teams and everything right now, and more specific stuff. You guys ready? Woo!
Cool, thanks, Doc.
Yeah.
So just to explain that a little bit, let me actually go back. So basically anything with a GUI, I mean, everyone has a script that they kind of want to bring to life, right? So yeah, we're basically looking for anything with a GUI, but the 2 categories that we're actually going to be judging on, so there's going to be top 3 from each category is going to be for the admin app, the admin-facing app, and the user-facing app. Does that make sense? Yeah, cool. So, the deadlines. Come up with a team. Actually, you should probably come up with an idea first for an app. Then come up with a team. So do that as soon as possible. The date for the next meetup is still TBD. I'm hoping to get that out soon. And then we're going to have our meetup in September, next month. That's going to have 2 awesome workshops I'm talking about in a bit. Shortly after that, you'll have to submit your team. In late October, very end of October, we're going to ask you to submit your app. And then the top 3 from each category is going to be announced in early November, and then we will have our actual event, where the top 3 will present and we'll announce the winners. So next meetup, September, we will let you know the date and the venue soon. And we're going to have 2 awesome workshops. This is going to be classroom style, so bring your laptops. We're going to do one with the web UI workshop with Jesse Peterson, and then an OS 10 UI workshop with James Barkley. So super excited about that. Hope you all can make it. Cool. Our October meetup is going to be at the JNUC in Minneapolis. So that is going to be Tuesday, October 13th. There are limited tickets, so once that goes out, swoop up a registration. And it's going to be at Dayblock Brewing, what we did last year. Huge success, really, really fun. Hope you all can make it. Who's going to the JNUC this year? Just curious. Cool, 10-ish? Awesome. Great. Well, thank you all for coming out. Thanks, Yelp, for hosting. Thanks, Ivan. Thanks, Jason. And yeah. What? Jam. Oh, thanks, Jam, of course. for being our lovely sponsor. We're going to Thirsty Bear after this, and I heard that someone may be buying drinks. I will not bust them out. This guy, Paige, with code 42. All right, hope you guys can make it. Have a good night.
Yeah, so we're going to do the presentation, the videos, we're going to put that on a blog post, probably by tomorrow. So you should go to Macbrained.org, go to the website, and there's, it'll say blog.